In college algebra, we wrapped up 5.2, systems of 3 variables. We did page 1 yesterday. We're going to do page 3 today. I'm going to go a little faster today, and these are a little harder. Number 3 is not as hard as number 2, but number 4 is definitely harder. You see this gap right here? That means step number 1 is done. So this step right here, make a variable cancel with 2 equations. The way they already printed it, it's like that decision was already made for us. Y is canceled. That means when we do step 2, we need to pick y. Make the same variable cancel from a different pair of equations. We're going to make y cancel from, with, I should say, equation 2 and 3. So if we multiply this equation by -2, we'll create a -2y, and the y's will cancel. Just copy equation 3 as is. And look at that, the y's are going to cancel. We get -x, -3z, and -50. For step 3, we're going to use the 2 new 2-variable equations to cancel another variable. Now you can pick x or z, but x would be very easy. Look, we already have a -x, and we have a +x right here. If I just simply add that equation to that equation, the x's will go away. Very convenient in this problem. So the x's cancel. We get -2z and -42. Z is 21. Step 4, I'm out of room on my steps, and I'm running out of colors. Back substitute to find remaining variables. So I'm going to plug 21 into either of the 2-variable equations. I'm going to plug it into that very first equation up there. So we're going to say x plus 21 equals 8, which means x equals -13. Then let's plug -13 and 21 into any of the 3-variable equations. Let's plug it into the second equation. We have -13 plus y plus 2 times 21 equals 17. So we get 42 minus 13, that's 29. Subtract those, and we get negative 12. And that's it. All right, now the hard problem. They're trying to model this situation with sleep data and death rate because they believe sleep is predicting a death rate. So, for example, look at the death rate when you only get 4 hours of sleep versus 7 and 9. So 7 seems to be better, lower death rate. This is a very backwards problem, and they suspect that it has a quadratic relationship. So we're going to work very almost inside out because our variables are going to be A, B, and C. We don't know what the prediction equation is, but we can create it using X and Y data. That means I'm going to plug in 1682 for 626, 7, and 967, 9. And I'm going to solve this system just like I did earlier for A, B, and C. Now, if you want to rewrite or skip that step that I just wrote and instead write 16A plus 4B, 49A plus 7B, 81A plus 9B, that'll look a little better. So I'm actually just going to rewrite it down here. Whoops, not plus. And then walk through the steps. I'm going to make the middle equation negative so that I can combine it with equation 1 and make C cancel. You can pick any letter you want, but C will definitely be the easiest to work with. So we're going to go 1682 and the rest of that equation, and then make the second one all negative. And the C's cross out. We get negative 3B. We get negative 33A. And you need to subtract those two, and you get 1056. Let's do the same with equation 2 and 3. So negative 626, negative 49A, negative 7B, negative C, 967, 81A, 9B, and plus C. And again, the C's cancel. I did this earlier. We get 341. All right, now we're on step 3. We need to make a different variable cancel. So let's make the b's cancel. Let's multiply this equation by 3, this one by 2, and we'll create 6b and negative 6b. So we end up with 2112 and 1023 and the B's cancel. Divide both sides by 30, and we get 104.5. We still need B and A, so I'm going to plug 104.5 into one of the two purple problems. Doesn't matter to me. I'm going to plug it into 341. And I multiply those two, subtract from 341, divide by 2, and I end up with negative 1501.5. Now I need to plug in those two numbers into one of the original equations. I'm going to plug it into the 967 equation. Whew, barely. C ends up equaling 6016. I'll give you full credit if you write it like that, but here's the fancy way to write it. Plug in your estimates. And then this equation can be used to predict death rates given an average number of hours of sleep. All right, hope that made sense. See you later. Bye.